All right, simplify each radical expression, express with reduced indices and rationalized denominators. Okay, basically they're saying you need to simplify this stuff. All right. Now we're going to do this in pieces. Okay. The first we're going to look at is 3 square root 12. And we've talked about a prime factorization or factor tree. We start with 2, 3, and go on from there. Can 12 be reduced? And the answer is yes. Always start with 2. 2 times what number, Josh, gets you back to 12?
6.
6. And then you try it again. Does 2 work again, Josh?
Yes.
Okay. And then you look for pairs. There's a pair of 2s. So you bring that out. 3 unfortunately has to stay inside. So just the square root of 12 becomes 2 square root of 3, but you bring this 3 down to multiply with it.
Mm-hmm.
Does that look familiar? We have done that a bunch.
Yeah, we did.
Okay. So this becomes 6 square root 3. Okay.
Mm-hmm.
And then the next one, there's actually nothing to do. So we're just going to bring it down. It's minus 8 square root 3. For the last one, though, the square root of 27, we're going to do the same thing, a prime factorization.
Mm-hmm.
So Josh, does 2 go into 27?
No.
But 3 might. Does 3 go into 27?
Yes.
How many times?
So 9. So
9.
3 and 9.
And then you try it again. Does 3 work with 9?
Yes.
3 and 3. If you see a pair, you circle it. Comes out. So it becomes 3 square root of whatever's left inside, which is the other 3. And then you bring this 5 down.
15 square root of 3. Okay.
Yes. So it's 6 square root of 3 minus 8 square root of 3 plus 15 square root of 3. When you have all the same roots, you just combine the coefficients. So what you really should see is like 6 minus 8 plus 15.
Mm-hmm.
And then you're going to bring the square root of 3 with it.
Okay.
Can you tell me what that becomes, please?
17. Right?
Try again. 6 minus 8. You have $6. You have someone $8.
Oh, so -2.
And then 15 to go with it.
That would be 13.
13. Good. 13
Yeah.
square root of 3.
13 square root of 3.
So as you can see, a bit more work there because there was more reducing to do before you could combine everything.
Okay.
All right. Number 22. All right. 3 square root 2 times, now we're multiplying, we're not adding anymore, 4 square root 6x. Okay, so you can multiply the numbers on the outside. So 3 times 4, that's 12. Then you can multiply the numbers on the inside. Square root of 2 times the square root of 6x. That's the square root of 12x.
Okay. 12x.
And everything is still multiplied together. I'm just leaving space because we're going to work kind of on, if we had to, we work on each part. We really just need to work on the root on the right.
Mm-hmm.
All right. So the root on the right here is really the square root of 12 times the square root of x.
Mm-hmm.
Could you reduce the square root of 12? It's just like the last problem we did. If you need to, you can even look up at your notes from that.
12, 6, 2 and 3, 2, and then outside, yeah, and then inside like this. That would be 2 square root of 3.
Yes.
X.
So 2 square root of 3. There's a square root of x, and then this 12 comes down. So again, if it's outside the root, 12 times 2, 24. If it's inside the root, you just multiply, and that's your final answer.
I'll be right back. My dog
Sure.
wants to come inside.
Got it.
Okay, I'm back.
You're back. All right. So multiplying, you multiply this stuff outside the roots. You multiply the stuff inside the roots.
Mhm.
Okay. New problem here. Let me know when you're ready or if you need to get caught up on any of that last stuff.
Okay.
All right. So here we go. One of the things that's different about this problem, it's not like the homework where you get a couple like it. The indexes are different.
Mhm.
So we need to rewrite both of these in that exponent form. So the first one is x to the 1/2. Can you tell me what the second one is?
X to the 1/4.
Good. Now there's this rule, this property that says if the bases are the same and you're multiplying, you add the exponents. So here you're going to add the exponents. So a couple of options. One, you go right to a calculator. Two, you can make a common denominator, right? 1/2 plus 1/4. You can make a common denominator 4. Add the tops, keep the bottoms.
Mhm.
All right, now that means our answer is x to the 3/4 power. But according to the instructions, we need to actually write it in the root form. So you have to be able to go backwards. Like the fact that square root of x is 1/2, we need to go backwards. We need to know where to put each of those numbers. So is the 4 or the 3 the indice that goes here?
Ooh. The 4.
Yes, yes. And then the 3 must go in the other place. And that looks to be your final answer for that.
Okay.
All right, 24.
Mhm.
Go. Man, you get some tough questions here for just kind of where you are in the course.
Yeah.
They're not doing you any favors. Okay, so whenever you see a square on the outside, you want to think of it as the thing that's inside the parentheses times itself. Times itself. Okay, it's not anything else. You have to rewrite it as this plus this. And I could always give you a numerical example to show you why this is if you don't believe this or you don't like this. But at this point here, we would FOIL.
Mhm.
FOIL. So 6 times 6, we're going to do that first. 6 times 6 is 36. 6 times the square root of y is 6 square root of y. Square root of y times 6 is 6 square root of y. And then square root of y times square root of y is, and you can write it here, it becomes just y. And if you're not sure, don't know how that works, we'll look at that here off to the side here. It's really y to the 1/2 times y to the 1/2.
Oh, okay.
And we just said that when the base is the same and you multiply, you add the exponents. So it becomes y to the power of 1.
Okay.
So this is 36 plus 12 square root y, because there's 6 of them on the left, 6 of them here, plus just y.
Okay. I have everything written down.
Awesome. Give me just 30 seconds here.
Mhm.
How are you doing in terms of like being done for the school year? Are you like, do you have a lot more tests? I mean, how are you doing in that regard?
What I have here, I'm just gonna look in the math book. I have- So the next 9 to 10. So I would have up to, so we're on test 8 and my final test would be test 12.
Okay, you got a little work ahead of you, but that's okay. All right. So here we go. New question 25. Solve each radical equation. Okay. The instructions tell you to check for extraneous solutions. And we'll get to that in a moment, what that means. We did not work on any problems like this, so I know this is going to be all new unless you've been doing some work on your own. One of the things I'll show you off to the side here is that to undo the square root of x is you square it. The square undoes the square root, and this becomes just x.
Okay.
So when we have this equation, x plus 6 equals 1, we will be squaring both sides of the equation. And on the left, the square undoes the square root. So it becomes just x plus 6 equals 1.
Okay,
How do you solve this equation?
this one what we're doing now?
Yep. How do you get x by itself?
You would subtract 6.
Good.
Subtract 1, both sides.
Yeah.
0, and then -5.
-5. Now, it says to check for extraneous solutions. What that means is you have to take your answer and go back to the beginning. This is the check part. And you put -5 in for x. And you work it through and you decide, are these the same? What do you say?
Yes.
They're the same. Okay. And you might be wondering, like, well, why are we checking if they're the same? They're in the next problem, we'll probably see one where that's not the same. But that is the idea here. It's kind of like anything else you do in life. It's good to check to see if what you think, is actually going to work. You cut a 2x4 to go somewhere for a project, then you go over and, see if it actually fits, right? You don't just
Yeah.
be like, yeah, it probably work. All right. So number 26 we'll get to. Let me know when you're ready for this.
I am.
Great.
Everything good to them.
So same thing as the last problem here. To undo the square root, you use square. But you have to do it to both sides. So on the left, it's nice because the square undoes the square root. It becomes just x plus 8. On the right, this is kind of like that problem we were doing earlier where you have to rewrite it like this. Is it clear why I'm expanding it in this form when it's x plus 2 squared? Okay. Okay, great. Now, would you mind kindly, Josh, foiling this on the right here and letting me know what you come up with?
The x plus 2.
Yes, times the x plus 2.
Okay. So the first would be x squared plus outer would be 2, 4. No. Okay. Do you want me to give you the whole answer?
Yeah,
or
go ahead and tell me. Yeah, tell me what you come up with.
Okay. Let me just cancel these. And four. Okay, so I think I have an answer. 4x squared.
Okay, so x times x is x squared. Start with that. And then x times 2, what would that be?
X times 2x.
And then 2x, 2 times x is
2x.
And then 2 times 2.
4.
Good. All right. So then you can combine. I heard cancel. Think of it as combining. 2x plus 2x, that's 4x plus 4, or grouping them together.
Would be 2x, 4x It's 4, okay. And then,
So now you can subtract x from both sides and subtract 8 from both sides.
mhm,
So you have x squared minus, I'm sorry, plus 3x minus 4.
okay. 4. And I think that's it. We're gonna go
Well,
to
we
the
actually
math.
have to factor this.
Oh, really?
Yes. Okay, so we're going to factor now. We're trying to find two numbers that multiply to -4 that but add up to +3. Okay, so just because of the, I want to make sure we get through everything today. I'm going to give you those here. So 4 and -1, they multiply to -4. 4 and -1, they multiply to -4, but they also add to +3. All right, is that okay?
Mhm.
All right, now you're going to set each of these equal to 0.
0. 0, okay.
And then you're going to solve for x. What are the two x values?
That'd be x4 and then x -1.
So you're moving the 4 to the other side of the equation.
Oh, okay. So then that would be x plus 0 would be x.
You're subtracting 4 from both sides.
Oh, okay.
So x is
That's a
-4,
0.
and then you're
Yeah.
adding 1 to both sides, x is 1.
Oh, okay. Interesting. Okay. Let me write this down. X is 4. Plus 1. 1. Okay. Circle all this.
All right, now we
All
have to
right.
check. So I know it seems like, wow, can't believe this problem can keep going on, but we need to check. So we have to check. We have to check both of our answers in the original.
Mhm.
Okay, so to do that, we put -4 in for x. So it's the square root of -4 plus 8 equals -4 plus 2.
Okay. Okay. Right there.
Yes, so what's the square root of 4
Oh,
on the left here?
sorry. Somebody's knocking on the door, so
Okay,
sorry for my dog.
no problem. Don't worry about that. If you need to get up, you can, but what's the square root of 4? Let's get,
Okay. Square root of 4. There's 8. -6.
square root of 4 is 2.
Okay,
And,
2.
and what about on the right here? What's -4 plus 2?
You got 4. Oh, $4 gives us so -2.
-2. So are these the same?
Uh no.
No. So -4 is not a solution. So you cross it out.
Okay. So let's do
Okay, now on the right, same thing. Same thing. It's the square root of 1 plus 8. Does that equal 1 plus 2?
9. 3. I would say yes. Hesitating.
Yes, they are the same. So this one is a solution.
Okay. Wow. That was a lot of work for one problem.
Yes.
Okay. And now I need, oh no, I still have some more
We got
pages.
one more.
Okay.
All right,
Wow.
you ready?
Yeah, I think so.
Okay, let's look at 27 here. I think this is the last one on this page. Is that right?
Yes.
Thank goodness. Okay. So so the first thing here is we're going to add 5 to both sides. So it's
Okay.
the square root of 3x equals 9. That's not too bad. And then like we've been doing in the previous problems, we're going to square both sides. So that's 3x equals 27.
Mhm. Okay. And would I have to get rid of X?
You have to divide by 3, yes.
Okay. That would be both sides. X equals 24.
You're dividing by
Okay,
3.
bye.
Yes. So your check here is to put 9 in for x. I'm sorry. I messed this up here. This is 81 when you square 9. And so when you divide by 3, it's 27.
Oh, okay.
Okay. And it's important because the check doesn't work if I don't do it that way.
Ooh, I'm confused. 3 and then 3x. Okay.
Okay, now the check is you take that x value and you put it in for x, and then you see does it work. So on the square root of 3 times 27 is the square root of 81.
Mhm.
Square root of 81 is 9. 9 minus 5 is 4, and these are the same, so it works out.
Okay. Oh, wow. And do we have to do more
That's
with
it.
this problem?
No,
That's it.
that's it.
Okay.
That's it. Yeah, that's
Okay.
it. So I do know you sent something else over, so I'm just uploading it now, and we'll take a look at it here once that's ready. There it is. All right. Here we go. All right, so here's the first problem I'm seeing. Is that right?
Mhm.
All right, so we're writing each equation in what's called standard form. Standard form means that all the variables are on one side. Okay, so all the variables are on one side, zeros on the other, and they're in descending order.
Mhm.
So variables, one side, descending order. Do you know what I mean by descending order here?
Like a from A, B, C, D.
The exponents, 2,
Oh, that's fine.
2 to 1 to 0.
So biggest to smallest.
Exactly. That's what
Okay.
descending order is. Ascending is the other way.
Mhm.
Okay. Now, to do this, you have to do this first in this problem here, you have to subtract 6x from both sides. But when you subtract 6x, it's like, well, where do you put it? You put it after the x squared.
Okay.
Has to be in descending order. Okay. And that's it. It just says to write it. It says do not solve. Do not solve. Just write it.
And 2. Whoops. X squared. Okay.
Okay. Next question here. Same thing. You're going to put it in standard form. So that there's the choice here. The choice is, do you move everything left or do you move stuff right? And the answer is it depends on what you want to, what you like. There's not a right or a wrong here. Traditionally, they teach moving things left. So we probably should do that just to be consistent with that there. So notice that when I subtract the x, I'm putting it under the 4x because it's going to combine with that.
Okay.
So if we just rewrite this, it's 3x minus x squared equals 2.
Right. Two, right. Right. Okay.
Okay, but we're not done because it doesn't equal 0. So we have to subtract 2. And there's nothing to combine it with. So you kind of just put it off to the right here. So it's 3x minus x squared minus 2 equals 0. This is all out of order, right? We want it in descending order. We want it to be ax squared plus bx plus c. It doesn't have to be all positive. It just has to be the x squared first. So this negative goes with the x squared. So that's going to come out first. So if it's negative x squared, there's really a plus there with 3x, so plus 3x. And then you bring the 2 down as well. So see how we kind of reorganize it a little bit?
Okay.
All right. The other thing here that I'm seeing is that maybe there's some uncomfort or you're not sure about how to move things. When I say move, and that's one side to the other, you're typically adding or subtracting. Okay, so we want to move, and number 3, move this minus x squared to the left. How do we do that? How do we undo this negative here, or the subtraction?
You would plus it, or
Yes, you would add x squared to both sides. Now, is there anything to combine it with on the left? Are there any other x squareds on the left?
No.
No, so unfortunately, that's just going to stay kind of right there in front. X squared plus 4x plus 3 equals 0.
Okay. And then should we reduce?
Well, let's ask ourselves, is it in the standard form? Is it in this ax squared plus bx plus c form? Is everything on one side of the equation?
Yes.
Yes. Is it in descending order?
Yes.
You're done.
That was surprisingly fast.
Well,
Okay.
they're going to slow down. All right, number
Sorry,
4.
my dog again.
Sure. Yep, take your timer. I'm going to grab some coffee. I'll be right back. Give me 30 seconds. All right, I am back. Let me know when you are as well.
Okay.
All right, you ready to go?
Mhm.
Okay, so just like the previous problems, we have to first put this in standard form. What do we need to do to put this in standard form?
We need to go from, we need descending
That's
order.
right. But before that, what do you have to have on one side of the equation?
0.
0. So how do we get a 0 here?
We would add 1.
Add 1. Is there anything to combine it with on the left?
No.
No. So it just kind of lingers. Maybe put it in the end there. So it's x squared plus 2x plus 1 equals 0. Now the rest of the instructions say to solve by factoring.
Each cut out by factoring. Okay.
Okay. So there's a bunch of different types of factoring that we might see. This one is called a perfect square trinomial, which isn't really important, but it would shorten it if you were really really fast at recognizing the type and knowing how to do it. If you don't recognize it's a perfect square trinomial, you have to go back to the basics, which is two numbers that multiply to 1 but add to +2.
Mhm.
So can you think of two numbers that multiply to 1, okay, but then they have to add to 2?
And 1 times 1.
1 times 1, you got it. So 1 times 1, that also adds to 2. So this becomes x plus 1, x plus 1.
1. Okay.
And the idea is if you were to foil this, it would add up to it would go, but you would go back to the previous line here.
Oh, okay.
All right, now you set each of these factors equal to 0. All right, could you solve those for us, please?
Okay. I would assume I would have to get rid of the 1.
That's right.
Subtract by 1 both sides. So 1 and 0.
You're subtracting 1 from both sides, right?
Mhm.
What does that become?
X equals 0 minus 1. Be 0 minus 1. -1.
Okay.
It's the same thing for the other side. -1.
So they're the same.
Yeah.
That's fine. Your solution is x equals -1.
Okay.
All right, we're going to jump to 6 next. We will come back to 5, but it's more difficult. We're going to do 6 next, though.
Mhm.
So let me know when you're ready.
4. 4 equals 0. Okay, I'm ready.
So is this already in standard form?
Yes.
Why is it in standard form? What are the 2 requirements?
It needs to be descending and
Check. Yep.
and then what was the last one? Descending and forgot that last one. 0 something.
Equals 0. Yeah.
Equals 0. Okay.
All right. So 2 numbers that multiply to 4 is what we're looking for. Multiply to 4, but then add to 4. So the 4, this is the one that's multiplying to, always the last one, but then adding to the middle one. So what 2 numbers multiply to 4?
2 and 2.
2 and 2. And does that also add to 4?
Yes.
So this becomes x plus 2, x plus 2, like that.
Equals 0. Okay. And then will we do FOIL or
You don't want to go backwards. What did we do in the previous problem?
we subtracted?
Not yet. Right before
Right.
that.
We did that's
See,
what I'm saying.
we're at this line right here.
Mhm.
We did something. We got what we went to the, let me do it, show it here. What is that arrow pointing to?
We removed the parentheses.
And set it equal to?
0.
Yes. Yes.
Okay.
So you can do the same thing here. You're going to remove the parentheses and set it equal to
Okay.
0.
All right. And then we would do it like the last problem.
Yes.
Okay. 52, subtract by 2, subtract by 2. X equals -2. Both sides. And they're the same. Okay.
So your answer is -2.
Okay. All right.
Feel like you got it?
Mm-hmm.
Okay, good. All right, so number 5 and number 7 are another type of factoring that you'll need. I call it grouping. Let me grab 5 here. These are more involved. So this is in standard form. Descending order, got 0 on the right, check, all good here. Now in the previous problems, there was no coefficient in front of x squared,
Mhm.
but this time there is. So when there's a coefficient in front of x squared, you have to take the 2, or the first number, 2, and multiply it by the last number, positive 7. What is 2 times positive 7?
14.
14. Okay, so here's what you're now looking for. Multiplies to 14, adds to -9. Multiply to 14, but adds to -9. So the hint here is that the two numbers are both negative.
Mhm.
So can you think of two numbers that multiply to 14, but add to -9?
Uh, should be the other way around. Still no. Hmm. That equal to -14. Okay. Wait, no. That's still not correct. Ooh.
All right, so I'm gonna, then I can hear some struggling. So -1 and -14, okay? -2 and -7. Those are the only two possibilities.
Mhm.
Do either of those add to -9?
Let's say 2 and 7.
-2 and -7. The sign's important. It really is. So the next step here, and this is not really obvious, but what you're doing is, let me actually do it differently, is you're taking that -9x and you're converting it to -2x minus 7x. And then you're bringing the
Okay.
first one down and you're bringing the last one down.
I'm gonna write everything down. 13. Oh. +7. Okay.
All right, now it gets a little bit easier from here. You look at the first two terms and you find the GCF. What is the GCF between the first two terms?
Greatest common factor.
Yeah, between the 2 and the 2, what's the greatest common factor between them?
No. I'm gonna say the x squared.
I'm asking about the numbers between 2
Oh,
and,
the numbers. So
yeah,
then
2 and -2. Start with the numbers. What's the largest number that goes into both 2 and 2?
2.
2. Okay, so the GCF is 2, and then followed by, what's the smaller exponent between x squared and x?
X.
Okay, so there's your GCF. So what you do is you write your GCF on the outside and you divide each of these by the GCF.
Okay. Now I'm remembering something. 2x. 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 7. 7. 2x. Okay.
All right, now we got to divide here. What is 2 divided by 2?
1
1. And then x squared divided by x,
x
x. So just x. You can write 1x. What's 2 divided by 2 again?
1
And x divided by x?
1.
Yes. So x minus 1. Now you immediately write what's inside parentheses over here to the right. So whatever you get over here on the left, you write over here on the right.
Mhm. Okay.
Now
Everything
you have
done.
to figure out what goes in this missing position.
Mhm.
And what goes here is the number such that when you multiply in, you get back to the previous line. And usually it's good to look at the constant. So what do you multiply -1 by to get back to +7?
Oh. Uh, -7.
Yes, good. Okay, believe it or not, we're almost there.
Oh, really? Wow.
Yeah, almost there. All right, so now go ahead and get caught up here. Next step's important too. They're all important, but trying to get it to kind of sync up here.
I have everything down.
So notice they both have an x minus 1.
Mhm.
You can factor out an x minus 1 from both. So when you factor it out, what is left over? The 2x.
There's 1 and 2x, and then -7. Do you hear me? So, uh-oh. What's going on? Oh, do you hear me?
Should you be able to hear me?
Yeah, okay. I'm sorry.
That's okay. So
Okay.
it was with the internet. I just saw a little drop there. Okay. You're going to set each of these equal to 0. X minus 1 equal to 0. 2x minus 7 equal to 0.
Mhm. That's 1. Okay.
So what do you do to solve the one on the left?
You would subtract, no, you would add 1
Good.
to
So
both
x
sides.
equals 1. Good.
And then for the right, you would add 7 to both sides.
Good.
7. So then 2x equals 7. And then x equals 1. And then I would assume we would have to get rid of the 2.
Yeah, you divide by 2. Good. And you
Mhm.
just write it as a fraction.
Okay.
All right. So just I want to make sure we get through the last problem. So let's or number 7 here before we close out. So did you get everything down for this last one?
We were doing number
5.
5. Okay. Yes, I have everything down.
Okay, so I'm just going to work through this. I'm going to give you the steps, but your objective here is to just get everything written down.
Mhm.
So it ends up being 4x squared minus 3x minus 10 equals 0. You're just moving everything to one side of the equation.
Okay.
So let me know when that you get caught up to there.
I have it
All
written
right.
down.
So this time you take 4 and you multiply it by -10. 4 times -10 is -40. And you're looking for two numbers that multiply to -40 but add to -3. And it ends up being 5 and 8. But this time the 8 is negative.
Mhm.
Okay, so we're going to rewrite this minus 3x as minus 8x plus 5x. Bring the 4x squared down. Minus 10 equals 0.
Mhm.
Just like the
Okay.
previous problem, you got to find a GCF here. So the GCF ends up being 4x. So you're dividing both of these by 4x. That becomes x minus 2. And then you immediately write x minus 2 over here. So go ahead and get caught up.
Mhm. Okay.
And then the number that goes in here such that when you multiply n, you get back to the 5x minus 10. So if you look at the 2 here, 2 to 10 or negative 2 to negative 10 is 5.
Uh-huh.
Okay. And then you factor out the x minus 2 from both, leaves you 4x plus 5 equals 0. And then he said each of these equal to 0. The one on the left is 2. The one on the right, you have to do it to subtract 5 and then divide by 4. So x ends up being minus 5 over 4.
Okay. Yeah.
So we do not have enough time to get through the next few problems, but I'll just put a note here that this would be the next thing we would work on in the future. So we're gonna have to go ahead and stop right there for today.